Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and have you ever wondered how to levitate your balls? Well, today we're going to build a device to do it. So stay tuned, we're about to get extended. So today we're going to be taking a look at an ultrasonic levitator. And what this is it's effectively just two ultrasonic emitters, and they're going to levitate some plastic balls by using very high frequencies beyond the range of human hearing, and make them levitate in space just by vibrating the air around them. It's a very simple project, so we're just gonna get a few things organized here and we'll get started. So all of this is SMT, which is surface mount technology, and effectively it's very, very small components. And it's gonna be a little bit difficult to solder. So what we're gonna use is standard fine tip soldering iron, set at 750 degrees Fahrenheit, some very fine solder, and we're also going to be using some desoldering braid, which will help us in actually removing excess solder, since it takes very little in order for it to attach these particular components. Now, we don't have a lot to go off of. This is actually it. So we only have this schematic, and it shows us what the values are of the particular resistors. So we're going to have to go through and test them, because there's no way I'm going to be able to read any of these just because of their size. There's a few LEDs in play, as well as a few ICs as well to generate these signals to be able to drive these devices right here, which are the piezo emitters for the actual ultrasonic sound. And it's really just a metal plate attached to the end of a piezo crystal. So not a lot going on there. There's two of those, and it will effectively levitate the balls in between them, which will be mounted to these two plates. So, very few things. I think it's only going to take a few minutes. I'm going to fast forward through a lot of this as we're going through it, just to save time. And today I am trying out a new solution for the fume extractor, which hopefully should be a lot quieter and also a lot more effective. Just an extension hose, pretty much, but larger diameter. So now SMT components are often shipped like this, this is a cutoff of a reel. So there'd be a long strip, it has this little track guide mark here to register, and some pins when it's in what's called a pick and place machine. And a pick and place machine will actually automatically attach these particular devices if you're going to assemble this type of PC board on a production line. Now, obviously we're not going to be doing that here, so these pieces are going to be very, very small to work with, and probably very inconvenient. So we're just going to try our best. Tweezers are a good idea, but I don't know where mine are, so we're just gonna improvise. So first, looking at the schematic, we see we have a 10K resistor, and that is the only 10K resistor we have, which is likely this one right here, since that's a pack of 1. We have 5.1K resistors right here, so there's 3 of those. So R1, R3, and R4. There's 3 right there. There's 4 capacitors, and I can tell these are capacitors because they're a lighter color. And that's generally the rule of thumb, is that resistors will be black and capacitors will be closer to a lighter shade. It doesn't always work that way, but it's a good guess if you're going to take a tester to it. We do have a larger capacitor as well. So that one's easy to identify, and that's through hole, so that's easy enough. We have header pins, which are actually for power input. We have what looks like an op amp, and this one's very, very tiny, but it has 5 pins. Could also be a power regulator. So this is TPS 7933, and we see it has an input, an output, an enable, a ground, and not connected. So that takes the voltage in through a 10K resistor, has 5.1K to ground, so it looks like a standard voltage divider coming in here. So 12 volts in, and looks like probably 3.3 volts coming out, just because if you look, 10K plus 5K is 15K, plus or minus, so that's about a third of the 12 volts coming in, so 4 volts or so. We see there's also 12 volts coming in, going through a capacitor, which is the 10 microfarad, which should be this right here, which this is 10 microfarad at 50 volts, even though it specifies 16, which would be a smaller capacitor. That's perfectly adequate. Then we have C1, which is 0.01 microfarad, which would be these. and then just a straight connection to ground, etc. And then we have a 0.1 microfarad here, which is another one of these. And then it's 3.3 volts coming out. So it does look like it is a voltage regulator just coming through. So it's using this voltage divider as the enable pin, and then the enable, or the input, is taking the VCC 12 volt input once again, and then that's stepping it down to 3.3 volts. So unregulated source for the enable pin, and then a regulated source coming out of the TPS 70933. So next, we have a loose component, which I should be wearing an anti-static strap, but I am not. And if you can read that, because I can't, just shows you how small these components are. So that is our STC chip. And we see it has an A in, a B in, a P3.1, P3.0, P5.5, all of which look like they are not connected. Then we have the 3.3 volt coming in from the MCU. We have a ground connection. And then we have our LED connection. So the connections that we have here is P5.4, which connects from our VCC 3.3 MCU, which is the TPS 70933. That connects through one of our 5.1K resistors. We have also one of our 0.1 microfarad capacitors. And then we have our LEDs. So these are our LEDs, and we can tell because they have a clear top, and you can kind of see the LED element within them. And those, of course, are polarity sensitive, so we will need to verify that using the diode setting on our multimeter. And that connects to P5.4 on this chip right here, which is the SDC15W204S. We then have power going to the chip from our MCU. We have P5.5, which we'll see if it's connected in a second. I don't see that it is. We have our ground connection, which obviously just goes to ground. We have P3.3, which is AN, and then actually goes down to another chip down here. Our BN, which is P3.2, which also connects down to our another chip down here. P3.1, which actually goes to our pin header right here on pin 3. And then P3.0, which connects also to our pin header. Then we move down to that chip, which is the TC4427, which is this chip right here. And we see pin 1 is not connected. We have in A, which is AN coming from the SDC15W204S. We have our ground connection. In B, which comes from the other chip as well. 8 is not connected. Then we have A out, VDD, which is coming from our power supply connection, but it looks like it's actually the direct 12 volts, which is the reason for the 12 volt rail on this particular device, is it needs the full 12 volts to drive the piezo driver. And that's just going through a 0.1 microfarad capacitor. And then we have B out going to the second piezo driver. Okay, the pin header is very straightforward. It just has our 3.3 volt MCU connection, our P3.0, P3.1 connections, and a ground. So very straightforward on that. We have a power indicator as well that just takes the 12 volt input, runs through a 5.1K resistor, which is one of these, goes to the LED, and then just straight to ground, just to show that there's power there. And then they depict the power connection itself. So this is this barrel connector, which is pretty standard, and it actually has 3 pins on the bottom. And we see one of them is for power, which is usually the center pin, and then the ground, which is the shield, has a second pin, so when you actually plug it in, it will make a second connection. That way you can actually, if you had battery powered devices, for example, you would be able to detect that something was plugged in. But that actually breaks this connection when something is plugged into it. So if you ever do test any of these with a multimeter, you want to make sure that something is plugged into it before you test which pin is which, if you're going to use it. But generally the one on the back is the center pin, and then one of these two will be the actual side connection over here. So let's get to assembly. So first we're going to start with our smallest components, which are going to be our resistors and our capacitors, and our LEDs. And trying to peel these when they're not attached to a full reel is going to be near impossible. So we're going to do our best. So let's start with the LEDs. And we have our 2 LED locations over here, but we want to test polarity first. They do have a shape to them, which is going to be near impossible to see as well. So we set our multimeter to diode mode. Just going to touch it, we'll flip it around, and we see even it emits a small light. So now to determine the polarity, like it has a shape to it, so the smaller side is going to be our ground end. But the LED runs from VCC through our resistor first before going in towards ground. So we see there is a trace that actually goes between L2 and R4 on the top, and R1 and LED1 on the top as well. So that's going to be our positive side, which in this case is on the right. So it is kind of a U shape. Just grabbing these very gently. I'm going to grab a very tiny screwdriver as well. And we're just going to verify by testing our second LED, and we see it is lighting up. Right, so we kind of have them where we want them. So this should heat up fairly quick. I'm going to try my best to stay out of the way of the camera. So we want to preheat the pad just so it flows nicer, then just tack it in place. There are better ways to do this. I don't have those tools, so we do the best with what we got. So we have our two LEDs soldered. We can just test these again. So we see one of them is over to here. Okay. So we see it is still lighting up. We'll reverse these two. This one just runs from any ground connection. And we see that that one is also still working as well. So next let's install the capacitors. In our case, all of the capacitors are the same with the exception of the through-hole components. And these are kind of just bricks, so we can just kind of lay them in place. But because these are all over the board, we're just going to place them in one at a time, starting from the top down. Right, so that's one capacitor. Let's do another. So those are our LEDs and our capacitors. Let's do our resistors. So R2 is our only 10K resistor. So let's go ahead and get that one out of the way, since that's the lone one right here. Okay, so that's that resistor done. Not the prettiest solder job ever, but it is certainly a decent connection. So far, so good. Next, we have 3 more resistors. Alright, so that's all 4 of the resistors. And obviously there's a little bit more solder here than needs to be, but I think it's perfectly adequate for our circumstance. Now we get to the more sensitive components, which are these little things. I'm going to do the one that's out of the package first, right? And that is the STC15W204S, which is U1. And there is a little dot here indicating pin 1. So we're going to line that up. It shows where the dot is. Right, we do see we have a solder bridge between those 2 pins. That's where we'll use the solder wick and just take care of that. Right, so now we don't have any solder bridges. I hopefully didn't cook it, but let's see. We'll find out when we try it. So next we're going to do our little regulator right here, just because it's going to be impossible to get to anyway. Okay. So we have this, and then we have easy stuff. Not the prettiest thing ever, but also not the ugliest. So that's the end of the SMT components, and now we have the through-hole components. So we're going to do our pin header next. Just goes facing this way. Easy by comparison. Next we'll do our capacitor. This does have a polarity, so we just match up the white line, short leg goes right there. Alright, we'll check. We are seated properly, so we'll go with that. We'll cut the legs. And last but not least, on this particular board is the DC connection. And for us, it doesn't really matter which pin is which, because they all just kind of slot into place. Alright, we'll make sure we are seated enough. Do the next one. So that's the bottom. That's the top. A little bit of the brown that you see is not actually burning, it's the flux inside. This is rosin core solder. If I was using separate flux, it would be a little bit neater, but probably still the same color, and that's just a cleaning agent that's used to make the solder adhere better. It removes oxidation later. So I'll put this to the side. Now we'll do these two. Now for this, it's got a polarity. So this should be plus, this should be minus. Just put it in, put it upside down, easy enough. With big pins like that, always point it away for you. Right, so that's done. And we do one more of those. So that is the soldering complete. Next we'll move on to physical assembly and then just doing some testing. Alright, so let's go ahead and assemble our actual stand. So it's these standoffs right here. Connects all of these together and actually acts as the electrical conductors to go between these platens that contain the ultrasonic emitters to be able to make them stand off together. Now, luckily there's no specific instructions, but I do have a picture just from the original listing. So it does include putting two of these together for each side of the long ones, and then add a short one, or I should say a medium one, onto the end of each of those. So we have those two standoffs right there, and what we're going to do is we're going to put the feet on here. So as we actually see, the trace goes over, touches this pad, and it looks like these two are attached together, these two are attached together. So as long as we put it on one way or the other, it should be fine. But let's just see if there's any polarity markings. And it does not appear that there is in particular. So I think it's just as long as they match each other, then it's fine. So we're going to take one of these feet and screw it on. And then we have two additional standoffs, which are short ones, and those are going to separate the top portion and the bottom portion. So it sticks through. So now it stands up nicely. I'm actually going to try and match it up to one of the pictures. So the T is facing away from the DC power plug. And we'll do that. First we'll try it with both of them, because it's not particularly clear which direction it goes, but when we try it, we can change it. And that's the completed assembly. So we can see it's got the PC board on the bottom, it's got the two emitters facing each other, and that's how it's able to actually go through and suspend the balls in the air. So let's actually try it out. Okay, so currently we do see it operating. Let's see if it works. So there we go. We can see that it is in fact keeping the balls in the air. Right, and it is done not anti-gravity, although it is levitation. It is actually the sound waves between the two transducers are interacting to be able to keep the balls in the same relative location, just because of the high frequencies that they're using in order to operate. So thanks for watching the video today. Leave a comment down below and let me know what technologies you find interesting, and we could see if we could do a future video on them. Also, if you want to see more videos where we build stuff, check out this ASMR soldering playlist right here. If you like the video, be sure to hit that like button, and if you haven't subscribed, please subscribe. It helps me out a lot. And then hit that notification bell, that way you know the next time we're getting extended. So until then, take care.